I've had this RTX 3080 Ti for almost a month now, and I think it's about time we tear it apart and reapply thermal paste. And by the way, as to how I managed to purchase this thing, I got it on Newegg Shuffle, which is basically a free program that allows you to enter to win the chance to purchase an exclusive tech item, such as the RTX 30 series graphics cards, the new consoles, and whatnot. I entered on the first try and got really lucky, so I purchased this with my own money. If you want to check out Newegg Shuffle, I'll leave a link in the description for your convenience. So I've only had this thing for a month. Why do I want to tear it apart and reapply thermal paste? What does that even do? Thermal compound or thermal paste basically just transfers heat, and I prefer to use my own thermal compound because it should be slightly higher quality and provide slightly cooler temperatures, which should give me slightly more FPS. Mostly I kind of just want to see what the PCB for this graphics card looks like. So this process, especially for such a new card, is not necessary at all. I don't want to see any comments of people saying, you did this for 1 degree Celsius cooler temps. Yes, I did, because I want to see what it looks like inside. And a couple disclaimers, I am not liable for any damages you may incur. This video is not a guide, and this could void your warranty. It probably wouldn't void a warranty for the EVGA graphics cards because EVGA supposedly allows you to open up your graphics cards and reapply with a fresh layer of thermal paste, but the manufacturer for your graphics card could be different, so I want to let you know about that. And yes, warranty stickers are technically illegal in the US, but I'm not going to say go ahead and tear apart your graphics card, so just do whatever you want to, but don't blame me if anything happens. But before we tear this thing apart, we have to heat this thing up first with the stress test and check how the temps look with the stock factory applied thermal paste before we apply our own. So let's go ahead and put this back inside my PC and stress test this thing. Alright, so I put the graphics card back inside my PC. We're gonna have to stress test it first with the current thermal paste before reapplying a new layer. I currently have Hardware Info 64 as well as Task Manager opened up to check the maximum GPU temperatures. And we're going to use Unigine Heaven benchmark just to stress test it. And I have it on ultra settings at 2560 by 1440p because this is a 1440p ultra wide monitor, and I still want to have these tabs open up to check the temps while that is running. We're going to run this for about 15 minutes just to make this thing as hot as possible and see what kind of temperatures we're getting. And by the way, I'll show the ambient room temperature like somewhere here on the screen. It is currently 66.2 degrees Fahrenheit. Alright, it's been about 15 minutes. You can see the maximum GPU temperature is about 74 degrees Celsius. We can just round it up. And the GPU is currently sitting at about 73 degrees Celsius. If you want to check out the other temperatures, they're right there, but we're going to focus on the GPU silicon itself. I'm going to stop this test and take out my GPU from here and then put it on that table so we can actually start the teardown. Alright, I am back from stress testing my RTX 3080 Ti for the Win 3 Ultra Edition graphics card. And it is pretty hot right now, so I'm going to leave it on the table just to cool down a little bit before I get my fingers on it. I don't want to burn myself. Alright, it's been a couple minutes. This GPU is starting to get a little bit cooler, so we can finally start the teardown. I have a secondary camera over here just to film the actual teardown part itself. So here's the graphics card. We're going to put this on the table. For the tools, I'm going to use an iFixit ProTech toolkit. I purchased this a couple years ago because it is an awesome toolkit. I'm unfortunately not sponsored, but if iFixit is watching this video, please sponsor me. So I love this toolkit because you get 64 different bits, as well as a couple other tools on this side. So for the thermal compound, I have a couple different choices. I have liquid metal, but I don't really want to use it because although the thermal conductivity of liquid metal is incredibly high, it is also electrically conductive, and if the liquid metal spills around all over the place, well, then I can kiss my almost $2,000 graphics card goodbye. So I'm not going to use this. Okay, but for the other thermal compounds I have that are not electrically conductive, I have Geely GC Extreme, Noctua NT-H2, Arctic MX4, Arctic MX5, as well as Thermal Grizzly's Cryonaut. Thermal Grizzly Cryonaut is probably the highest performing of this bunch, so I'll probably just stick to this. For the other tools, I'm going to use a spatula. This is going to be the bare GPU silicon. I want to make sure that every spot is covered, so we're going to apply a thin layer across the entire GPU. I'm also going to use isopropyl alcohol. This is just 91% from CVS Pharmacy, as well as some coffee filters to wipe off the thermal paste. But the first step, I believe, we're going to have to take out the back plate for this graphics card, and then we're going to have to do some more screws. Disconnect the fans, which are right over here. These are the fan connectors. And then I believe we can just pull out the PCB like this and leave the heatsink as well as the fan shroud on the bottom. So let's just begin. So I'm going to get my iFixit ProTech toolkit and just a Phillips head and start by taking off some of the backplate screws. Let me check my camera let me check if my camera can see this. So let's take out these screws, and I'm also going to try to keep track of all these screws. These screws over here. Alright, so I think I need to unscrew this nut over here that is holding up this backplate screw. So I'm gonna use my fingers just to kind of unscrew this, and this might take a while. There's basically a small nut right here. And there it is. So we can continue with the other screws. We got another screw right here. I'm not gonna do the GPU bracket screws yet because we can take out the back plate first, but let's do this screw here. More of these nuts. I think there was a tool in the iFixit toolkit, like this, that can unscrew it pretty quickly. Yep, there we go. Ready? The last screw for the back plate. And this is not coming out because that nut is still down there. But I don't know how I'm gonna reach this one. There is a nut down here holding this screw under this EVGA sticker. Almost forgot about this screw. Backplate almost comes out. It's just this one screw left. Okay, I just unscrewed it. Now that we got the backplate off, this is a metal backplate. Feels pretty sturdy. We can put this to the side and start examining this card to see how we can pull this PCB off the heatsink, so we can actually reapply thermal paste and clean up the GPU. Alright, so now we have 3 screws over here holding down the IO shield that we're going to have to remove. So let's get this one out. 1. 2, and 3. And there we go. This thing just removes that. So we're gonna have to look around the graphics card to see any cables that we have to disconnect. So we have 3 fan cables right here. They're blue, tannish, brown, whatever, and black colored. So these are probably to power the 3 fans. I also see another cable over here that I presume may be for RGB. So yeah, this cable right over here, it's kind of just trapped in there and I can't poke my finger in there to remove it. Okay, at least it's not as bad as Nvidia's Founders Edition cards, because you should have seen the 3070 and I think also the 3080, 3080 Ti and 3090, whatever. The Founders Edition cards had ribbon cables, which are just such a pain in the butt to disconnect. It's like tearing apart a laptop. Those things are disgusting. Unscrew the back plate for the GPU, pull out the PCB, and actually I think I could just leave that cable in there. I don't remember how I did this before. Okay, these cables are kind of a pain. Push on the clip so you can actually pull them down. So let me unscrew one corner a little bit, unscrew the other corner. Put this to the side. I believe we can just pull the PCB. Alright, I loosened up the PCB. I think we can just pull it up now. And we still have this cable on this side under here, so I'm gonna disconnect it now. Okay, there we go. And the PCB is pretty big. Bunch of thermal putty. I believe this is thicker thermal pads, and then the thermal paste over here. So now that we got a quick look at the PCB, isopropyl alcohol and the coffee filter to wipe off the old thermal compound. Right. So I'm just gonna wipe this off. Wipe off the old paste. Let me put the PCB to the side first and grab the heatsink over here so we can wipe off the heatsink, because this thing is pretty dirty. And the thermal paste looks dry, but it's actually just really thick paste because manufacturers usually want to just apply a thicker paste to prevent the pump out effect, prevent the thermal paste from seeping out of the sides. So this paste is not actually dry, it's just really thick. Gonna make sure this cold plate is extremely clean. So here's the PCB itself with the GPU all cleaned up. This is the RTX 3080 Ti. I'm not going to do a PCB analysis, so let me get some thermal grizzly cryonut, unscrew the cap. I think I should wipe the GPU one more time just to make sure there's no old paste there and to clean up any lint. Okay, looks good enough. Let me apply a little bit bigger than a pea-sized amount on top of the GPU. This looks good. Cap. Alright, now that the thermal paste is on the GPU, we can use the spatula to spread it around just to make sure we get even coverage across the entire die. I want to make sure that every spot is covered because I do not want any hot spots on the GPU. I want to make sure every spot is covered. So actually, I think I need to apply more. Either that or this Thermal Grizzly Cryonite is starting to get dry because it is not applying very easily. I'm not sure why. Alright, so yes, I know this looks a little bit messy, but more thermal paste on the GPU. Silicon is better than not enough. You definitely want to have enough because, like I said, I don't want any hot spots on this thing. There's no heat spreader on this like a CPU, so we got to make sure every spot is covered. And I don't know why this is being so difficult right now. I think maybe, oh, and I'm running out of Cryonite, so yep. Gonna have to. I think this is good enough. Maybe I don't even need to spread it anymore. Just trying to spread like a thin layer across. This is actually kind of difficult. And I think it could be because this thermal paste is drying up or something. Because usually Thermal Grizzly Cryonite is like very liquidy. But I don't know why this is being so difficult. Alright, so I think this actually looks decent. You can see there's a ton of thermal paste on the GPU. And that's not really that big of an issue. Because if there's too much, it'll just seep out the sides. This paste is not electrically conductive. Unlike Conductonaut, which is electrically conductive, so even if it does seep on the sides, it shouldn't cause any damage. But yeah, like I said, it's always better to have more thermal paste on the bare GPU than it is to have some hot spots where you aren't covering the GPU, because yeah, I want to make sure I have even coverage throughout. Yeah, look at that juicy thermal paste. Hopefully this triggers some people. If this triggers you, let me know in the comments. Alright, I think we're good now. Put the thermal paste on. I didn't really touch the thermal pads, so now we can flip this over back onto the heatsink and then screw everything down, connect the fans, and then check out the temperatures. So let's go ahead and do that now. Alright, before we put my graphics card back together, let's take a look at the heatsink. So you can see there's this large copper cold plate over here that is great, as well as 6 heat pipes that are pretty large and a huge aluminum fin stack. Yeah, this thing, it's pretty heavy too. So now that we've had a quick glance at the heatsink as well as the PCB and the GPU, we can just lower this down, put it back together. So let me see if I can actually put this cable back first. Yeah, let me lower this down, line up the cable, see if I can plug it in. Alright, I got in that cable. So we can just kind of lower this down, and I can plug in the fan cables a little bit later, but let me zoom out, and I also kind of have to line it up, make sure that I get this right. Alright, it's pretty much lined up. So first things first, let's put this GPU backplate back on. So let me get a screwdriver, and I'm gonna make sure I apply equal torque, or as equal torque as I can to each corner. So I'm gonna do that corner a little bit, this corner, the opposite corner, and then this corner, just to make sure there's even mounting pressure. There we go. So this is pretty much fully in. Let me double check it. We want to make sure there's enough mounting pressure on the GPU so that it's adequately cooled. Okay, so we can put the next up, we can put the fan cables back in. So here are the fan cables right here. Push it in. All right, that one's in. So we gotta line up this one. This one's not lining up straight. I don't know why this one's not lining up right. Okay, oh, I got it in. Got it. Okay, let me double check. Screw back on the IO cover. So we're just gonna cover it like this. This nut over here that has to be tightened. But this one down here is impossible to reach. One under the EVGA sticker that I believe they just use. I believe they just use stickers so they can see if you've torn apart the graphics card. Okay, I actually managed to get the last screw and nut in by using tweezers. So I basically just had to lower it down and then twist it using tweezers just to get it in there. Alright, so let's go over to my PC, install this thing, and then stress test it to see if temperatures have changed. Sitting around 72, 73 degrees Celsius about. So after all that, dropped about half a degree to 1 degree Celsius, and that's alright. I mean, is it really significant? Not really, but yeah. This process isn't really that necessary, especially for such a new graphics card. The paste hasn't really dried up yet. It's still pretty much brand new. So I wouldn't really recommend this for such a new graphics card, but if you have an old graphics card that you've used for at least 2 to 3 years, I would highly recommend replacing the thermal paste, because usually when paste dries up and it gets all cracked, it isn't as effective as when it was new. If you enjoyed this video, please like and subscribe. I'll link Newegg Shuffle as well as this RTX 3080 Ti in the description if you want to check it out.